everyone. Just getting set up here. Bear with me a minute. Okay, just about ready here. Just have to make a couple more button pushes, I think. Button pushing. Let me see here. To push the broadcast button. Okay. Okay, I think I am ready to go here. Turn off the chime. That would be a good thing. Find it here. Okay, let's get started. Welcome everyone to the Keshe Plasma Reactor Group for Tuesday, May 29th or Wednesday, May 30th, depending on where in this lovely planet you happen to be residing at the moment, or off planet, in which case I have no idea what your time scale may happen to be. In any case, welcome to the Keshe Plasma Reactor Group. And once again, we're gathered here to show things and discuss things that are related in a broad manner to what's called the plasma teachings and the idea of the plasma universe, you might say. That's magnetic gravitational fields and plasmatic entities, and sort of a different way of, actually a much different way of looking at the world and the universe. So let's dive into today's activities. As usual, I'd like to call on Lee Coates because he's there. Been there for a long time, very consistent. Here, just a second, let me put my headphones on here so that folks at home don't get an echo in the live stream.
Anyway, Rick, nothing to show this week.
Nothing to show this week. All right. Well, might just have to wrap things up and call it a night then, I guess. Well, okay, that's good, Lee. I'm sure you've got things going on in the background there and are plenty busy with one thing or another, being the productive guy that you are. All right, does anyone else have something they'd like to show here? Any topics for discussion? We have a couple of attendees. Let me promote you here, Shandor and Skywalker. Just checking your
Hello everyone. Hello Rick.
Hi Shandor, how you doing? What's
Thanks. Finally, thank you for being promoted as panelist, so I can start to record it from here.
Oh, okay. Okay, yeah.
So you remember last time I have remarked something related to the salinity of the washing water of Ganses. So now I started to wash a CH3 Gans, which is different from the previous CO2, and the same thing appeared. After first wash, I had a TDS around 400, second wash around 200 ppms, third wash about 100, and after the third wash, it just jumped up to 700 and something.
Yeah, okay. So it was normal in the first and second wash, and then the third wash it jumped up.
Yes. And after that again, it's decreasing. So this is confirming the idea that something happens there around the connection between the salt and the Gans. So the Gans holds on the salt for a while. So you wash it, and suddenly it reaches a condition of changing the balance, and suddenly a lot of salt is released, which was withheld within the Gans.
Odd.
Let me find a trick how to share the video in spite of it's not allowed by the host.
Oh. Let me see.
For instance, I can start a camera program, and I can share that screen, if that's fine.
Yep. Should be able to start video there now if you need to.
Okay, I've chosen the screen sharing.
Mm-hmm.
Maybe it's not the highest resolution.
Yeah, it looks really clear so far.
Yeah, it's a 640 pixels, I think, but no problem. So now I let it all the night to settle down. So this is the fade bottom. So there is actually more gas here. It's well compacted. Now let's take a little probe for testing, and I take a clean cup to avoid previous salts to influence the readings. Just I want to wash first the TDS meter to make sure there is no salt attached. So it's good after each measurement to rinse it in distilled water. I cannot see well because I'm remote from the monitor. Is it visible, the reading?
Right there, yes.
I can push the hold button and to bring it closer.
You have to tilt it a little bit. So
it's a 0000.
Right, yeah. Mm-hmm.
So it's
any better than that.
It's fine. And now let's measure the Gans water. It still has a lot of orange color floating things inside, and you see immediately it's stirred up. So it's very difficult to separate it. It is 150.
Yeah.
I hope it's readable in some angle.
Yeah, we could actually, I think, read it better when it was in the cup there for some reason, that the light was good at a certain angle. We could see it. That's not too bad there. You can see it. Yeah, okay.
Let's adjust the lights. It's morning and my windows are toward west, so maybe it's better.
So is this the, sorry, is this test number 6? Is that, oh yeah, okay.
Yes, 150. So first wash, it was 219, which is surprising because it should be about 2000, which is not even readable. So the TDS meter reads up to 999 only. Above that shows error. So the original salt which I used, it was 3.5%. But perhaps as the Gans has formed, it fixed some part of the salt. And after just 2 washes, it was not released, the most part of that salt. So first wash was 219, second 117, and at third it jumped up to 713. And now it's going down. At fourth is 428, at fifth is 220, just reach the same value as it was after the first wash.
Yes.
So probably that's why it's needed to dissolve the Gans by rinsing it not just 3-4 times, because after 3-4 times you may be still in the area where most of the salt is holding to the Gans. Fresh water.
So if you would have measured your salt water at first, would it be like 350 grams or something around there?
I used to have 3.5%, so 35 grams to 1,000 grams of water. To 1 kilogram of water, about the 350 grams of no, not 300, 35.
What would the TDS be then on that? Would that be
3,500 parts per million?
500. I see. Yeah. Okay.
Now, Shandor, if the meter measures up to 1,999, if we look at the scale from down below going up, 220, 428, 713, it could be 1,117 and 2,000.
No. The TDS meter just shows error or just 3 lines if it's above 1,000. It has only 3 digits, so whatever it's above, it's shown in a different way. I can show you that. Just a second, let me replace this water.
Well, I'm asking that because I've never used a ppm meter.
Of course, this has to be confirmed in other ways, because TDS meter is an electronic device which measures the electric properties of the water. And if we have a plasmatic material like Gans, funny things may happen in the electronics as well. So the confirmation is there is another method, but it's more difficult because you need high precision balance. It's to take a sample of water, salty water, and just evaporate everything which is not solid, and to estimate the quantity of the solid which was remaining after evaporation. So this will be the 7th wash. Probably it will go down to around 80, 90. Actually, I found that's needed that 14, no, not 14, 15 to 16 times the washes to get the total dissolved solids below 10 ppm. Of course, if you have a really clean water, you cannot make it cleaner than the water which you use for washing. Okay, this one down. Now this is still the Gans water here in this cup. So this is to go to the rest. This has to be shaken well. Take out as much as possible of the salts which are inside. Okay. And let me show the TDS meter how it shows with the real salty water.
What would it show with the Gans mixed up the way it is there now? Would it be over 1,000?
It should be.
Yeah.
Oh no, this is not the right salt water. This is 800 only. So I need to bring some salt here, or to make another solution which is calibrated. So allow me some time to get a clean bottle, but I have one. And to make a fresh salt water, just I need the balance and the salt. It's some nice Italian salt.
By balance, you mean a scale?
I have a scale somewhere, and I just bought some fresh batteries for it. Let's see where it is today. This is a retired kitchen scale. It's not very beautiful, but it's still working well. I'm sorry. The digits may not be really good, but you can trust my measurement. So, how much to prepare? 1 liter?
Sure, that would be good. It's easy to measure then.
$35. It's about 2 spoons, 2 full spoons. Just for reference. Now I need a measuring cup. So this is a half liter one. Here is the 500 milliliter sign. I should put a visible mark because this is very transparent. Okay. And clean water. first half liter. And second half liter. I want to dissolve all the salts from the bottom. Needs a little time. It's not quite like sugar in the hot water. By the way, if you try to dissolve the stable salt in hot water, it doesn't dissolve any better than in cold water.
Yes, I've read about that. It's an interesting fact. But sugar will dissolve a lot faster in hot water. It's different structure.
Sugar, yes, definitely. Definitely. I will need to make some noise. So I bring the how to say that?
Hand mixer.
Yes. If it's too noisy, you can unmute me for 2 seconds. But I suppose neighbors. Am I muted?
I will mute you, but I didn't. The noise canceling, automatic noise canceling started to kick in there, and it
Yes.
canceled part of the noise.
Yeah, sometimes when I am a meeting, even if I am a host, I am already muted. I sneeze, and immediately it pops up a flash that you have been muted. So Zoom has an automated feature for muting these other noises. There is some salt, so I have to stir it slowly as well. Stirring rod. Stirring rod may be needed. It's here. Or a spoon. You see, it's not much salt, it's not 300 grams, which should be a saturated one. It's just 35 grams of salt, 1 liter of water. Let's taste it. It's pretty salty. Just bearable. It's like the seawater. And the TDS meter, just what happens with it? It should be recalibrated probably, because it shows 827, which should not be okay. I'm very much surprised at this measurement.
Well, I'm reading about TDS meters, and it mentions in Wikipedia that there can be significant errors. There's a conversion factor and so on for.
And in the meanwhile, I measured the plasma waters with it. You remember how often the multimeters got out of order and unusable after measuring such a plasmatic things. So normally that should read well above 1000. So anyway, this is about my personal TDS meter. Can I trust it or can I not trust it? There are some errors. 782 right now. So, as a conclusion, always measure if you can, and don't trust one measurement. And don't trust one single method of measurement, but repeat it with different ways, with different technologies of measuring.
There's another instrument called a salinometer for measuring salinity, and it measures both the electrical conductivity, which is what your meter measures, and the specific gravity at the same time. So it is more accurate apparently for...
Yes, if you use it for measuring salinity and not something else. It's maybe calibrated to a kind of salt, and with other salt it may be different. You see, so many people have made plasma capacitors, and because they are capacitors, they started to measure the capacity, electric capacity. And in certain conditions, they were so happy that they got supercapacitor of several microfarads or farads. But they did not consider how those capacitors work. So I can tell about that with a little illustration. So I need a new share and a whiteboard. It doesn't want. I have to stop first this one. No, it goes well. Just my full screen camera program covered everything. Okay, so a new share with a whiteboard. So how we measure capacities? Normally, we know how to measure resistance of a resistor. We make a circuit, we have a power source, a generator, which brings a DC current through a resistor, and somewhere we insert here a milliampere meter or an ampere meter. We are measuring the current, which is easy to be measured. And we know, and based on a known voltage, we have a voltage, let's say U in DC. Knowing that voltage, knowing that current I, the value of the resistance is calculated. So we have no instrument to measure the electric resistance in this way, but we measure the current and we calculate with Ohm's law. We know that the current is equal to voltage divided by the resistance. So the higher the resistance, the smaller the current. The higher the voltage, it's the higher the current for the same resistance. So resistance is calculated by voltage divided by current. Now for measuring capacitors, the thing is a bit different because what happens if we have a DC current source that will charge the capacitor. Oh, sorry. we'll charge the capacitor up to the same value of voltage. Let's say we have here this voltage of the generator, and the capacitor will have a transient, this is time, and this is current. So this will go up, and it will no, sorry. Let's make it easier. The current will be big, and it will go down here. Meanwhile, the voltage will go up to a value within a certain time. So the UC will be equal to UG within a fraction of a second if we charge that. But that's influenced also by the internal resistance, electric resistance of the circuit. This is not something to measure the capacity. So what to use? We know that the capacitor allows certain frequency alternative currents to go through. So in this case, they use a high frequency generator of a known voltage, but this is an AC. And it's closed the circuit via something which I show here is a milliampere meter, but it's not so simple circuit because it's an AC, so it should be a special circuit here. But the principle is that the capacitor will act as a reactance, which is not R, it's not C, it's an X. And with a complicated formula, which includes the frequency and the voltage and the current measured, it's calculated how much is the capacity. So the capacity is not measured directly. It's the result of a calculation. But what happens in these industrially made commodities called capacimeters, you have a high frequency generator, and you have a measuring part. And the measuring part usually comes with a rectifier, which can be 2 diodes or 3 diodes or whatever number of diodes. Oh, sorry. So first of all, you have here diodes in the circuit somewhere. And this can be in various cases. But first of all, you have somewhere a diode, and not just one, usually several diodes into the circuit. There can be several types of circuits. So when you are supposed to measure the capacity, you are supposed to use a capacitor which does not leak any DC. So it's a complete insulator here in between, and it does not leak any DC. And and a high frequency current is passed through it. And depending on the capacity and the frequency and the voltage of that high frequency power source, a bigger or smaller current will go through. And the capacity is calculated by a rather complicated formula. It's done in electronic ways, no worries. But you are not supposed to connect there a voltage at the entry. So you have your capacity meter. It has the plus and minus. It has the probes. And you are supposed here to connect a capacitor. But many people connect there a plasma capacitor, which is also a battery. So they have in practice a circuit which contains some capacity, but in the same time it contains a DC power source. And the capacitor, the capacimeter, the measuring instrument is not prepared to handle any DC input. So what happens if this voltage gets above a certain value, let's say above 0.65 volts, then the diodes within the measuring circuit will be opened. Just by that bias DC which you apply. So all the measurement will be screwed up and you will get false values. You assume that you measure the capacity of several microfarads, and in fact it has a few nanofarads capacity, and it has a DC voltage at the entry. So in all cases, you have to understand how your measurement method works, what's your instrument measuring, and to understand what can influence that measurement. I said about the TDS meter, it's a good handy tool, but it's not faultless. It measures the electric parameters of the water. It never weights how many milligrams of salt are in so many milligrams of water. If you want to know that, you have to take a little water, to put it into a vial, a glass vial, and to boil it, to evaporate it, and then you have to scrape off those micrograms of salts and to weight them on a very sensitive balance. If you have not a very sensitive balance, then you have to increase the quantity. So instead of measuring 1 gram of water, you have to measure, let's say, 10 kilograms of water, where you can detect the grams of dissolved salts in even on a kitchen scale.
Yeah, not such an easy task for sure.
Yeah.
So maybe the taste test is the best way to do it. Dilute until it doesn't taste salty.
And no, because if you have a TDS of 200, which is pretty high, it doesn't taste salty at all. It's just like normal tap water. So taste has a limit, and that limit is due to the salinity of your own body. How much salt do you have in your saliva? 0.8%, 0.9%, 0.1%, or how much?
Something like that, yeah.
So you cannot go below that in sensing.
Well, they say that they did tests on drinking water and the TDS meters, and people enjoy the taste of water if it's under 300 parts per million, and it's sort of so-so water if it's between 300 and 600, and after it gets up into above 600 and especially above 900 and 1,000, then it gets into some pretty nasty water apparently.
Yeah, those are called mineral waters. Sometimes you have mineral water springs with sulfur salts or with whatever. One is good for the kidney, other is good for liver, other smells bad and it's good for the stomach, and so on. Really, the drinking water should be between 100 200 ppm or something around that, or below that. If it's above 200, it has a bad taste of too much lime in it. It's like the water from some certain bad fountains, and if you want to wash with real soap, it doesn't make foam.
Right. Yeah.
Lower TDS is better. And I like the taste of the distilled water, for instance, which is so sweet. It reminds me of the artesian spring which we had in our village when I was a kid. We had several springs of over 100 years age, which were drilled to the depth of about 350 meters. And it was a very nice, clean water. It was slightly warm, maybe 35 centigrades. And the women from that village were very famous for making so tasty food. But the secret of a good tasty soup is to have a very clean water for it. If the water is a heavy, it's a hard water, in that case the soup will be not so tasty. So besides of the skill, a big part of that fame was the water of that fountain. So anyway, maybe it's not 100% reliable to just estimate the TDS with a TDS meter, but in certain range it's fine. Just I didn't understand why now I made that dissolved water and it's shown a low TDS, lower than I supposed. Maybe is my salt still at the bottom, and I measured only the top. Still, I have to stir it, but the taste is enough salty anyway. So I was expecting a TDS about 3,500, but anyway, for the low value, I can trust, I hope, the TDS meter. I see the difference between the different distilled waters or tap water. So still it happens that phenomenon of diluting, and suddenly the salinity of the Gans water increases when we go after several washings, after several rinsings. So I suppose the Gans is connected, plasmatically connected to the salt ions, and they are in certain balance of fields. And when that balance is somehow overcome by a certain dilution, in that case, suddenly it releases a lot of salt which was withheld within. Think about the Ghana experiments about cleaning the water from dissolved solids by using Gans. Where they go, where those dissolved solids go after you treat the water with Gans. They go to the bottom together with the Gans. Think at the Fukushima decontamination measurements, where a smart German guy told, no, why don't you measure the mud at the bottom? Because that's separated. So it's, the Gans is not making anything to vanish, but it makes it to separate from the rest of the water and to settle down much faster. So those salts which are cleaned out, they are at the bottom. And those can be washed out in a certain process later. You know, this household reverse osmosis or whatever water filters. They have different mechanical filters and membrane filters. And in order to get 1 liter of drinking water, you use, let's say, 2 liters of tap water. Because part of the water is used to flush back whatever was into the filter. So first you have a filtration, and second you have a flushing, a rinsing of the filter itself. And that's a wastewater. So you use more water. How you clean? With water. You wash with water. So in this case you wash water with water, and from a medium contaminated water, you get a very clean water and a very dirty water. It's a separation when you use those water filtering units. So here as well, the water is cleaning the Gans, but the Gans is also cleaning some of dissolved solids from the water. And by flushing, washing, rinsing the Gans, those captive or captured dissolved elements can be released again from the Gans. It's something interesting which, if somebody has a better analytical tools, so then somebody may study more in depth about that. So many technologies can be developed from here.
There might be a practical use for it because of that hump effect there, that, you know, it somehow holds the solids, the salts.
Yes, so you have we have now so many membrane filters. So how about to make a membrane filter which has an active decontamination element, which is the Gans or a mixture of different gases, and then the Gans which will capture some part of the dissolved things from the water. So it will clean the water. The Gans itself has to be washed again and flushed to get it clean.
Yeah, perhaps it works on a gradient basis where it absorbs a certain size or weight of salts and a certain time range, and then another weight at a different time range, and releases them at different times. There might be a way of separating salts, the different salts that are dissolved or different dissolved solids. Maybe they could be released sort of like time released in layers, releasing the lead, releasing the radioactive, and so on in different stages, so they could be recollected.
Yes, and don't forget that principle. So you have a filter. So let's say this is the filter in a cylinder into another cylinder. You have some connections to some water which goes through here, some which goes through here. You get some filtration. This, let's say it's the exit. And a system of valves is needed for after you capture here some of let's call it contamination of the water. You will need a reverse flow. So you have a one flow which filters, and then you will need a reverse flow via another valve, via a system of valves, which should flush out whatever was the contaminating material. So this is how all kind of wet and dry filters work in an industrial area. So once you have a flow which filters, and then you have for a short time a reverse flow which cleans the filter. It cleans the sieves. And that's getting like a heartbeat back and forth. Now my drawing is not very clear, but maybe somebody understands the explanation. You understand, like if you have a sieve, you put here some flour which has some big parts of it, the flour falls off, it's fine, but you will have the filtered bits here. So if all this goes by let's say an airflow, in that case sometimes you have to reverse that flow and to get rid of the filtered bits. So you have always a two direction movement, back and forth. One for filtering and the second for cleaning the filter itself. You don't have that into your vacuum cleaner because you have the cleaning process manually. But in an industrial non-stop working one, it should be an automated that it also cleans the filters. So anyway, that's not the subject of the plasma technologies. We have so many smart engineers and inventors and innovators who can figure out such an applications. I just wanted to say that it seems after repeated experiments that the Gans holds within its wet stage a part of the salts, which is suddenly released after a certain critical dilution of the salts from outside. So you have a salinity inside the Gans, and you have outside in the outside water of the Gans. And when some balance is changed, in that case, suddenly a lot of salts which were withheld within Gans got released into the water. And I've heard voices saying, "Oh, we wash only 2-3 times the Gans because it gets too diluted and so on." But actually, you see, after the third or fourth wash, sometimes you start releasing the huge quantities of salt. So if you want to really eliminate the salt, in that case, you have to wash it about 15 to 16 times. Suppose that you always rinse it in double quantity of water than the original volume of the Gans. So let's say into 1.5 liter bottles, bottle like I had on the table, you put half liter of Gans with water, and you add another half liter of clean water, so you have a total 1,000 grams or 1 liter. You shake it up. That's why you have an extra space in the bottle. You let it to settle down, and you remove the added water. And if you repeat that about 16 times with very clean water, in that case, you can say you remove the salts. And that water, of course, you can use it for refilling the same boxes in which you are producing the Gans. So it's no problem for that. If you check the salinity, if it's under 300, you can use it to wet your flowers or whatever you want. Just don't put salt water on the flowers. They will not like it.
Unless it's diluted well enough. And apparently there is a fertilizer that's from salt water that is simply diluted salt water.
Yes, many things are marketed, but I'm not sure which is really good for plants from those. So many times potassium is marketed as good for the plants, and here in Hungary in the 90s, in 94, 95, an engineer who had several patents of very good multivariable measuring systems, he made a test on the field with plants, and he has demonstrated that adding potassium into the fertilizer is just increasing the cost of production. It's a myth that potassium added to the fertilizer is good, because there are huge quantities of potassium salt. After you desalinize the water, there is a lot of potassium salt, which is not useful for practically anything, but some smart people find a way to market it. They mix it with azotates, with nitrates and phosphorus salts and so on, and they say it's good for the plants. And actually, if you would use that potassium without being mixed into the other two components, the nitrogen and the phosphorus, you would find immediately it just kills your plants. It's too much for them. Yeah. Small quantity is needed, which is already available in the earth, very small quantity.
I read that 90% of the fertilizers used in production, food production, and use in the United States comes from the scrubbers of the natural gas power plants.
Always is a joint business connected.
Exactly.
And I don't want to enter into those details. You don't want to know the truth, and others also don't want you to know the truth about.
They didn't want to have all the contamination in one spot, so all these scrubbers, they scrub the gases off the exhaust pipes going out of the power plant. They didn't want to put it all in one place because it would be like a big toxic dump. So they decided we need to spread this evenly all over the ground, all over the dirt of the country. So they made it into fertilizer, which, you know, NPK, nitrogen, phosphorus, potassium. Those are the three big ones in fertilizer. And nitrates are great coming from the exhaust flume, are great for fertilizer. But it's also got all the other heavy metals involved that came from the natural gas, and radioactivity and the whole works can be in there.
Yes, so they say it contains.
That's why they spread it evenly in all of the ground, so that it yes, the radioactivity goes into all the soil, but they say that it's doesn't increase, at least very much, the background radiation that's already in the soil, supposedly. But
Yeah,
count that it's accumulative. You add this fertilizer year after year after year, and that radiation level just simply keeps going up.
Thank you for pointing that out. It's very similar to what I found in the late 90s, in 99. It was my ex-wife loved to buy such organic products with natural ingredients. Once she bought a big low price 1 liter shampoo or such a shower gel or soap, liquid soap or whatever. It was written with big letters on it, with organic oats extract.
Organic
Oats, it's a cereal.
extract.
Yes.
Okay.
And when I read the small letters, okay, they may have added something there for being fancy, but amongst the ingredients there were huge quantities of acrylic resin. You have to know about acrylic plastic resin that, for instance, in the hazardous materials list of California state, it's mentioned as a possible carcinogen. It can cause cancer. So even if you want to import a computer keyboard which has acrylic, you get a warning if you want to bring it in California. I was looking for a replacement keyboard for an old computer, and it popped up a big warning for it contains acrylic, which is hazardous. It's not good even to touch it as a keyboard. And that's the nice plastic, the shiny one.
I didn't know that about acrylic.
Yeah, and I know as I worked in such an international trade business with plastic resins, I know that huge companies who had everywhere in most continents some factories, they moved to Hungary, where I live, all the plastic injection molding for acrylic before Hungary joined the European Community. After Hungary joined it, they just moved all the acrylic things to China. And I say of huge name companies, and they have factories in Spain, in Mexico, and so on, but they never produce acrylic parts. Why? Probably because they have too big taxes for environmental protection, because it's a hazardous material. And since that, I see that in the most expensive cosmetics appear new ingredients. Acrylic resins and styrene resins, which is more dangerous. So one of the ways to get rid of hazardous waste, because chemical factories still have them, it's very simple. Put it in cosmetics, because in cosmetics there is no limitation in certain countries for that.
Yep.
Name it, it's a hydrating agent. Yes, you cover your face with plastic, so you cover your pores, and transpiration doesn't go out, so it hydrates because it doesn't let you dry out. Like those green apples, which you wash them for half an hour and still they have some waxy thing on them to keep them beautiful even after 1 year on the shelf. I had a friend who cut in half such an apple, tried to eat, and he abandoned it. And after 1 week, the apple on the cut surface was still white, which is not normal. Normally in 30 minutes, it gets brown.
Yeah, they have new apples.
If the hazardous waste embedded into cosmetics or whatever, and people just put it on their skin, and they let it on the drain.
Yeah, most perfumes come from pesticides, so I mean,
Coumarin,
and that's the
like
way
coumarin, for instance.
highly allergic to most of those things. So it's
Ah,
just,
they are medicine also made of coumarin. Did you know that? It's anticoagulant, and it's also rat poison.
right. Yep. Well, man has ingenious ways of recycling and reusing things.
That's business.
Yeah, it's bad business, but it's business.
So we have to find better ways. So you say, I have heard Mr. Keshe telling about bringing new energy instead of oil and gas would do too much harm to the economy of this planet. Because not just, oil products and gas byproducts are not just fuels. They are raw materials for so many synthetic materials, for so many plastics. And seeing what happens with that huge quantities of dangerous waste and plastic waste, we have islands of plastic bottles and plastic waste on the oceans. I'm just thinking, do we really need that? I remember the 60s when the plastic was just in such a movie that, oh, I'd like to have something, a beautiful table made of plastic. They made a polymer. They made such a promotion by movies to make people to get more plastic. And now everything you buy is made of plastics and polymers, and you cannot do anything with the waste. You see, I'm buying candies. They are packed now not more in paper, but in plastic, in polypropylene. Where does it go? It's not degrading. It's a huge problem.
It's a big
Meanwhile, the
problem.
nature has such a wonderful things.
Canada just today made a decision to invest over $6 billion, B with a billion, into oil pipelines because the oil companies bailed on it and decided it wasn't lucrative for them. And so the Canadian government decided they would buy into it today. Made that decision on behalf of the people of Canada. And, it's like you say, it's got two sides to the story. One side says it's jobs and it's work for people and it keeps the economy going, and the other side says we don't need any more oil. What is that now, Shandor? Let me spotlight
Something more fantastic than any plastic. You see, it's transparent.
Yeah.
Look. Very tough, very springy.
Yeah.
Can you guess what it is that?
Well, it might be a seaweed, actually.
No.
No?
It's produced by nature.
It's not.
And you know, if you break it apart, you can tear it apart. Of course, if you beat it with between two stones.
Mm-hmm. You get fiber.
Very tough fiber. So this is a tendon or a sinew.
Mm-hmm.
So this spare part is from the stag's, stag, that animal with big horns, the stag's leg.
Oh, a deer, sinew from a deer leg. Oh, okay.
Yes.
Yeah, that's how they can jump over fences easily and so on.
And all is created by natural plasmatic process in the nature, and it's a fantastic engineering inside. Mm-hmm. You know, ancient cultures use this to make thread, to sew things together,
yes.
or they use it as reinforcement for the composite bows made of bones and antlers and wood and so on. And it takes some time to take it apart because the fibers, which are transparent when they are together, but they become white when you split them. The fibers just don't go straight; they go interwaved.
Yeah.
So it makes a very tough thing.
This is the thing the scientists have just discovered, this interweaving of the fibers that makes things so strong. It's almost like a spiral kind of structure, a double spiral thing where you have like our double vortex plasmas that we've seen. Structure.
This is a bit of the internal structure of a bone. So another wonderful plasmatic creation of the nature.
Mm-hmm. On the inside, it looks like sort of two crossing fields in a way. It looks like a intersection of sort of the two counter opposing fields that make the structure.
Trying to hold it still to let the camera focus on it.
Mm-hmm.
Oh, this autofocus is annoying.
Yeah, I turn it off on mine.
Yeah, but the new Windows 10
Yeah.
just killed my camera controls.
You mentioned that, yes. Yeah, that's a nice piece you got there.
Please focus.
Doesn't like it that close, I guess.
No, but it has phase detection.
Just a little bit further out and it was focusing on it. Right, yeah.
I'm trying to call the Skype tools options. And the video settings. And let's go to this camera. I have to move back on this screen, otherwise I cannot see anything. Webcam settings. White balance is again automatic, which I don't like.
Got more color there now.
Of course. So better I set it manually to daylight or to artificial light. So now it's... My skin doesn't look like a dead man's skin. And let's go to focus. And let's try to focus it manually on this. Yes.
There you go. Now I see it. Mm-hmm.
It's a wonderful creation of the nature.
Mm-hmm. Sure is.
Just created by the interaction of fields. What kind of new engineering would be that one? Which to replicate this one. So you don't need steel molds for casting or for injection molding, but you just have to have a pattern of fields and create something hard or something flexible or whatever.
Mm-hmm. I mean, they have 3D printers now that can print out similar to that bone structure layer by layer, but it doesn't necessarily have the overall integrity of something like that, I think, because it doesn't have the overall fields. It has the fields in a mathematical structure that it's trying to duplicate by printing out, but it's still far removed from the way nature does it to create a bone or repair a bone, which is quite
So get inspiration from the nature, understand how these structures are made and dictated by the fields, and they just grow where they need to. Have you seen Japanese farmers producing cubic watermelons?
Yes, right. Yeah. Yeah, in different
Because
shapes.
watermelon is created by the fields and they just fit the environment. And the Japanese, you know them from making bonsais, such as small trees,
Yep.
which used to grow big, but they make it small. And they just enforced the watermelon into a fish tank.
Mm-hmm.
So it has to grow square so you can pack easier when you load the truck.
Yeah.
All is natural, but they enforce the shape in such a way. Now think about not to enforce it by mechanical force, but to give the pattern where to grow and how to grow.
Well, this is the thing. Where does the pattern come from, in a sense, to create that bone that you were showing there as an example? I think the scientists are still having trouble with that one. They can't quite get a handle on. I mean, they talk about the RNA and the DNA and this sort of thing, but where does the DNA structure come from? That spiraling structure and into the all the information that's encoded in that and so on.
So the pattern is already encoded into the RNA and DNA.
So the pattern.
Can I pattern my own DNA or copyright it?
I'm not sure if you're allowed to now. I think someone else probably already has it.
It should be the end of all the copywriting and not copywriting, but the patenting things.
Mm.
So meanwhile, this all settled nicely. But I can leave it and it will settle down more further 2 centimeters. Shall we take one more measurement?
Sure.
Oh, this is salt water. It's brine. It sounds better than salty water. That's my word. This is balanced with salt. Yes, this is the clean one. It is 90. Sorry, I have no control over my monitor now. So after 7th wash, it becomes 90 ppm.
So that's pretty much in the normal range of what you'd expect if you're going to dilute it by half.
It's never exactly half. It's
right.
Let's do it, but it's something here. Let's say 40-60%.
Yeah. Huh. Interesting.
Let's give it the fresh water. Now my point is, my concern is how to separate the leftover floating gas from this water, because you see it's still an orange color. And I see tiny floating bits dancing through. Also the
Yeah, you might be better off to use like a syringe and put it in there and draw off the top, 10% or something, rather than disturbing the Gans at the bottom.
yes, possible. So I need such a pump, because I have maximum capacity of syringe 100 milliliters, and for 1 liter of liquid it will anyway disturb it badly. Okay, so I was not able to remove too much, so I fill it with water, and now I will leave it about 10 hours. I will touch it only. Now it's morning here, so in the evening. So we are filtering out the heavier part, and I'm wondering which is more valuable, the heavy one or the very tiny, fine one, which is in the water.
Sometimes we throw out the baby with the bathwater, as they say.
You see its color on the white background. Place the salt water too. Oops. Anyway, we need a lot of CH3 gas. It's the raw material for other nice things, and if you want an energy source, you need CH3. So thank you for attention.
Very good. Thank you, Shandor. It's interesting. It'd be good for other people to try that test and see if the dissolved solids go up before they go down again.
This is my main purpose, because you know, one test is not test, one measurement is no measurement. Mm-hmm. And it's good to change the variables, including the human part of it.
Right, exactly. So there's a valid experiment for somebody out there to dive into.
So I'm asking kindly the knowledge seekers, whenever you wash out the salts from your Gans, if you have the possibility to get a TDS meter, it's usually cheap, it's $10 or something like that, or below that. And try to measure and write down the total dissolved solids after each wash, and keep a log and watch for anomalies, like the trend is for the salinity to decrease at each wash, but at a certain dilution, at a certain number of washing, it just jumps out. And this is not by accident, because it's the third time when I observed. So please measure and note down and share the results. Probably you have a lot of places. We have focus groups on Facebook. We have a community website. So we can help about that.
Worth doing what's it called? The Keshe Plasma Scientific Journal, it's called. It'd be a great journal entry to do.
All is scientific, so let's not put the name scientific, just the, how to say, Gans and the salt solutions, or whatever. How to dissolve Gans, or people will draw their conclusions. It would be nice a system where somebody posts some article about whatever he wants, and later the users could attach different labels, of course checked by a moderator to not put wrong labels, and later to be to allow people to search based on those labels or on those tags, like the hashtags are on Twitter, for instance.
Mm-hmm.
That would be a helpful thing, because you see, I'm just washing the salts out of the Gans. So its purpose is to have a Gans with no salts. So it fits to Gans, it fits to salts, it fits to desalinization, but it fits also, somebody may find it, to the TDS meters, or it may fit to water purification.
Mm-hmm.
So one article may fit to several topics.
Yeah, it should be searchable database that way, so it's easy to cross-reference and find other articles similar and that kind of thing. Alrighty, what else? Is that it for what you have there, Shandor?
That's all for today.
Okay, thank you very much.
You're welcome. By the way, I have other things on my table.
Well, I was going
Thank
to
you
ask
for reminding.
if anyone had any questions as well for Shandor before we exit that part. But yeah, if you got some other things.
Just one thing. One thing more. You know, we like to play. And sometimes we find new toys. Or old toys get repurposed for new games. Mm-hmm. You see?
So
some marbles.
Yeah.
A big marble.
Big marble, little marbles, okay.
Now what for? Have you thought about putting an empty ball within a CO2 kit just in the middle of the plates and not floating on the water but down below? So put a marble in a net or in a rubber glove or whatever.
Yeah.
And use it as an anchor.
Yeah.
To hold down, to weigh down your balls. Otherwise, the balls will float. And the glass marbles are, I think, pretty much neutral from the chemical viewpoint. So it's not like putting a piece of lead or whatever.
Yeah, right. Yeah.
And they cost pennies, literally.
I see. Oh, interesting.
Just a suggestion, and you get marbles for different sizes of balls for whatever you need.
Mm-hmm.
Or you put in a plastic bag. I'm showing with a larger one. So you put a marble, you put your ball of desired size, and you immerse them together into the water, and your ball will not anymore go to the top, but it will stay somewhere in the middle.
Yeah, you could adjust it just exactly right to have it floating, the whole thing floating in the middle, probably.
Yeah.
And you can always adjust your salt concentration slightly to have it drop or rise if you want.
So I just wanted to say about that because I feel it's still actual. So people are trying to get into the new ways of experimenting. That's all for today. So.
All right. Thank you very much.
Welcome.
This is Marshvik. I have a few comments on this ball. I'm also doing a similar thing. And with the plastic bags, I have used nets and plastic bags and various other things to generate CO2 Gans. Plastic bags seems to interrupt quite a bit. And
of course, they are filters.
They're actually quite a big filter. And for example, when I do carbon dioxide with all the plates outside, I usually use glass, and it tends to work really well. If I use plastic bag, even at very close proximity, it doesn't work very well. So this has been my experience. That's why I recommend perhaps the string-based net to hang the balls. And I think that would work better. And I have also played with making the H2 tritium and doing similar things. I see that I have a similar problem if I use plastic. But I have tried using glass bottle with Gans, like carbon Gans, And it's easier to make tritium that way than using plastic. Plastic seems to cause problems for me. I'm not sure. But yeah, that's a much better solution, Chandler.
Yeah, and if you don't want a plastic net because it's still plastic, you can find such a cotton bandage for fingers, which is like a long net. You cut a piece and you pull it over the finger. If you cut your finger accidentally, you find it sometimes at the pharmacy.
Or it is possible to attach a tape at the top and just hang it from there. I'm using actually solid glass balls as well, which is empty ball, but yeah, exactly. And that works well. I've seen some interesting effects.
Also, you're doing such a nice things and you don't show us. So please put in public some photos.
Hang on a second, because we have some electricity problem. Let me just...
I understand.
Electricity power distribution. Hang on a second. Let me see whether I can get to it.
Yeah. That's why company where I worked before had such a nice business in Dhaka to assemble solar panels which are tropical weather resistant, because the population in Bangladesh is growing faster than the economy can grow the number of power plants. So in Dhaka you have such a power outages of 1-2 hours at least twice a day. So companies have to have backup power supplies and so on or hotels.
Good day, everyone. Good morning. Jalal here.
Hello, Jalal.
I saw you.
Hello,
had your
guys.
hand
How are
up
you?
there. We can barely hear you there. You have to get closer to your mic, perhaps.
The mic is already in my mouth.
Oh.
Sometimes it's working good, sometimes it's not.
Okay,
But
can you hear me clearly?
Yes, Moshe.
Yes.
Can you hear me?
Yes, Mosfek.
Pretty much. Can you hear us?
I'll turn on my camera. Hang on a second. Okay, so this is, these two are, I'm making tritium and hydrogen. And these are all using glass containers. And so this one has a carbon Gans field. It's a field differential, no wiring. So you see at the bottom here, CO2 Gans. And this one, so this is creating tritium, and this one is creating hydrogen. And you can see the color difference between the two. And this one is a mixture of CO2 and deuterium, because I have carbon Gans. Okay, this is carbon, and this is deuterium here. So the field difference is creating the field in the middle to attract the whatever CH2 field in this case, on the left, and carbon field on the right. So this is how I'm producing tritium and hydrogen. A little bit different, but I think I tend to like the field approach more than anything else. So I try to avoid wires whenever necessary, but it's working. So you see the color difference in both cases, both at the bottom deposits and as well as the top. And
it's wonderful. So what you have there on the right?
See the CH3 color, it's different.
Yes.
From all three are different. So there is a difference in color. Because there's been a question I've heard in some situations that what's the difference? I mean, they all look the same. No, they don't. They look all the same. They're from the same sample. So you do see a difference, clearly. So anyway, so this is one of the things that I'm doing. In terms of glass balls, this is an experiment. It's along the line of that flashlight that I'm doing. It's a little too early, but the basic idea I'm exploring is how to trigger the plasma. And so the flashlight, the reason I asked about flashlight last time is to get an idea of how you can use matter state to create the electron vibration or some sort of vibration. It can be magnetic as well. And once you have that, then you can trigger the plasma, much like lightning or any other approach such as that. But triggering the plasma is one of the things I'm looking into. So anyway, if anyone has any idea on that, I would be very interested in hearing about it. Well, that's all I had in terms of showing.
Okay, thank you, Mashfaq.
It's wonderful.
Lawrence, I see you have your hand up here. I'm not sure if you had a question or something you wanted to comment or show. Or any questions for Mashfaq or Shandor? Do you want to go ahead, Lawrence?
I want to add to MOSFET.
Well, you were there too. Yeah, go ahead, Jalal.
Did you try 1 to 24 to pull out the carbon from CH3?
Hello, good morning.
Say that again, 1 to 24. What do you mean by that?
The ratio?
1 to 24. The ratio is actually, this is carbon Gans. So carbon Gans with, I created carbon Gans, and the two containers have one, there is a mass ratio differential. So you create a field flow in the middle that creates the magnet which pulls the carbon out of the container. This is how I'm doing it.
Yeah, but are you pulling the carbon from the CH3 or you're adding?
I'm pulling because the field is at the bottom of the container. So the traction point is at the bottom.
You need to notice the ratio between your
the ratio difference. Yes.
Yeah.
Yeah, that's how it's done.
And if you go above 1 to 24, you have more pulling to the carbon.
It's the 6 ratio because it's carbon, just pure carbon. So it should be 6 or multiple of 6.
Okay, thank you.
That's how I'm doing it.
Thank you.
You're welcome.
Hello?
Oh, hello, Lawrence. Are you able to speak there now?
Yes, good morning. How do you do? I wanted to think about the empty boxes because when we use the different kits, the different setups, and we empty them, we supposedly have, we still have some fields in those boxes that we used, even though it's not the official method of putting an empty ball in. But since we've been producing Ganses in those boxes, I think when we empty the water and empty the Ganses, we still have the fields inside. So maybe we could use those empty boxes too for some kind of purpose. And in terms of plasmatic fields, even though we don't see them, they will still be there somehow. So maybe we can just use the CO2 kits or the containers that we used for capturing the Ganses to create field interactions. Maybe I'm too oversimplifying things. Let me know if it's bullshit. Anyone has any points to make regarding this perception?
From my understanding to the plasma, you are totally right.
Yeah, it makes sense. Once the containers are nano coated, they're basically they become a different um, plasmatic container than they were originally. You can actually measure fields coming from the containers with field detectors, electric field detectors, or magnetic field detectors, and so on. You can measure around the boxes.
We could even put the different size of boxes within each other, and like that create gradients of fields with simply the original CO2 kits or CH3 kits, and like this create the different plasmatic winds that we want to use for different purposes.
Yes. Mm-hmm. Yep.
And I don't know if you're open to this kind of discussion, but I wanted to talk about why I think we as humanity will have no choice but to go in the direction of using this technology in the future, in the present and future.
Sure.
And,
we can enter into that.
It's related to Mr. Keshe's explanations about the volcanoes and all the things, but putting it into a different, into a bigger perspective, a larger context. And there's been scientific measurements done that that the Earth's magnetic field is decreasing, like many percent compared to how strong it was in the 1980s. It's also related to the North Pole and the South Pole moving in and forth, but I don't think there's going to be a flip or anything else. It's just the strength of the field, the shield is decreasing. And by the shield decreasing, it's quite natural that we will have a higher influx of energies, whether it be solar or cosmic energies or however we may call them. And if we take a look at our weather patterns, because I think storms are like lightnings, are like earthquakes. They are different expressions of how energy is balanced. We have, even though we have low solar activity, like low number of sunspots and low intensity of space weather, we still have very strong Earth-related effects, like multiple tropical storms at the same time, more than usual. When I go out into the sun right now, even though it was spring and we would supposed to be having nice sunny weather, you go out and you enjoy the sunshine. I don't feel well in the sun. After about 2 minutes, I need to go into the shade as soon as possible because the sun burns. And if we take a look at earthquake patterns and volcanic activity is, in my opinion, also a form of release of energy, just like the earthquakes. And there's a big documented volcano eruption from 1883. The Krakatoa volcano erupted, and after the eruption, for many years, the sky was darkened. I mean, like a few percent. Global temperatures dropped by about 1 or 1.2% by the eruption of only one volcano. And there are also stories that, for example, the Roman Empire in the 1600, in the 1500 or 500 years, 583 or 600, broke down not because of the different Vandalic tribes roaming the lands, but because of some volcano eruption, and the food supply stopped for, say, 10 or 15 years. Because if there's not enough sunlight, if there's not enough heat, if there's not enough light, then plants don't grow as well as we're used to. And just like the Ark of Noah, when he got the tip that he should start building a spaceship and gather all the information and knowledge and put all the DNA samples inside his device to be traveling with him. We have gotten the knowledge just in time to be able to prepare for these, say, Earth changes. We can also dig underground, like many other cultures did before us, but there's much more elegant solutions, and I think this plasmatic technology is a much more elegant solution to all these problems. And yeah, that's what I wanted to share as an inspiration, so that we take ourselves seriously and have have some material inclination or to do something. Anyone have any comments, questions?
So for studying the phenomena of Earth's magnetism, I think human lifetime, it's not much relevant. If you want to draw conclusion, you have to study for millions of years what happened. Well, maybe you have seen such interesting theories illustrated with animations about Earth is growing. So somebody had the idea to cut out of paper the shape of the continents, and he could add them all together onto a smaller sphere than the actual globe from which he cut it out. So one of the theories says that Earth may be in continuous growing. And if you understand that it absorbs some quantity of fields and it releases a smaller quantity, in that case it's increasing in its weight and its size as well.
You can see the same growth on human people. When you take a look at the child, he grows up, and then originally the theory goes that after when you're 18 years old, you don't grow anymore. But if you take a look at elder people, they have much bigger heads than they used to have when they were, say, in their 20s or 30s, because even people are still growing with time. So
of course.
I agree with this theory of the Earth growing, and but I don't agree with you that you're saying that it's millions of years, because that's the established scientific theory as we have it right now. If you go to the Thunderbolts project on YouTube, listen to their theories with electric universe, and there's a website called Saturnian Cosmology. They all say that even though we as humanity have forgotten, there have been cataclysmic events within the time span of, say, 5,000, 8,000, 10,000 years. And all these events were, quite big. And yes, right now we are learning that in geology, that mountain ranges and the tectonic plates movements and all these things happened many million years ago. But just as with the plasmatic devices, within the blink of an eye, we have a little flash, and then the spaceship appears because it grows its outer skin. Just like that, we had different plasmatic interactions within the planets and the solar system, and they could have happened within the blink of the eye. So I think changes could have happened much faster and in much smaller time scale than our present scientists want us to, and the established theory wants us to understand and know. So if you take a look at my first idea, or the first point I wanted to say, is that the magnetic shield of the Earth is diminishing in a fastening rate. You can go to official NASA or whatever, any space agency magnetic field strength data, and you will see that the Earth's magnetic field has changed from the 1980s. It's a lifetime. When they say it's diminished, say 25% to 2015, from 1980 to 2015, we have 35 years. 35 years is half of a human lifetime, and the change is delta minus 25%. It's a huge change. within one lifetime. And in terms of Earth's lifetime, it's of course the blink of an eye, but we are experiencing that change. And also, there are also other shields within the solar system and outside the solar system. We are supposedly going through some kind of interstellar cloud, which is like, you know, when we're going through mist or fog, which also protects us from the outer cosmic type of radiations. And we're going out of this kind of foggy area within the space into a much clearer area where even more radiation is going to come in. It's like all the influx of these outer fields is like when we are putting the metals into the hot caustic. Much magnetic energy, you know, heat or whatever you may call it, comes in and has an effect on what we experience as matter. So,
very true.
So when we as souls, because we are mostly concerned with how we as souls are being and how well this soul incubator is working that we call planet Earth, we should create conditions, as usual, just create conditions, so that this process can continue on and maybe get even better. I'm not sticking to the human form. I mean, like we don't really need the bodies if we're considering the soul level, but it's still nice to have, you know. Supposedly, we are the fourth or fifth generation of what are called humans here on Earth. There have been many cataclysms, like, you know, the big flood, and the South American Indian cultures have different other stories, like, you know, the mud people, the stick people, who have been living here on Earth for some generations. It's not the official story of Homo erectus and all the other guys, but it's a form of tale that relates to the evolution of Earth and the evolution of the beings here on Earth. And most probably they have, you know, evolved as well in terms of what they identified with, whether they identified first with their bodies and the material plane, and then they realized maybe we're souls and identified with the spiritual part or the plasmatic part, or however you may call it. So that's what I wanted to say today. Please ask questions. Please, let's start interacting. The plasma of understanding.
All right, anybody have something they'd like to bounce off of Lawrence's comment there?
If I may, Rick, it's Doug here.
Yeah, go ahead, Doug.
In my part of the world, it's autumn, and I spend my day in the sun in my job. And contrary to past experience, I don't use sun cream or zinc cream or the customary lotions and potions they say you must wear to stop sunburn. And I think it's to do with drinking Gans water, because I used to spray things on, rub things on, invisible things and visible things, and still sunburn was a problem. But it seems not to be so now. And the only thing I can think that's different is intuitively, probably since drinking Gans water, I stopped using all those things and haven't had a problem. And the temperature is very balmy and nice, even though it's quite chilly in the mornings. But yeah, it's just an observation. And the clouds in my part of the world are absolutely gorgeous lately, fluffy white. The sky is intermittently sometimes covered in what they call chemtrails or whatever they are. I don't know. I don't care actually what they are. But then you'll have days of absolutely crystal clear, beautiful blue sky. And I think it's generally the influence of all the fields that we're producing around the world mixing together, and you may have some reactions somewhere that, just like Lawrence is saying, the atmosphere's thinning perhaps, or volcanoes may be going off, but it's all because the Earth is living, a living person or living being. It's constantly changing. It's maybe getting bigger and then getting smaller as she breathes in and out. The shape isn't going to be a fixed solid ball. It'll be influenced by other heavenly bodies, space objects in space, as Mr. Keshe is always saying. And as we move, everything is in flux. Everything is changing all the time. And that to try and say it's just heating or it's just cooling or it's whatever there is. Even guys have said the Earth is flat. I mean, you know, they had that idea some hundreds of years ago, and many theories exist. But in actual fact, the Earth is what it is. It's a living being, constantly finding its position in relation to other plasmatic fields that exist, and we're riding along. Like I was talking to Rick the other day about surfing. We're sort of surfing along on the Earth. It's our big surfboard, and we're riding the plasmatic winds and plasmatic waves and so on. And that's why nothing stays the same. We're born small, we grow big, we go back to being small again at the end, perhaps. We put on weight, we lose weight. Things happen to us. It just never stops. We think it's all solid and fixed, but just like the movie pictures, it's all a series of single moments joined in a long line, and taken one single frame, it's well, that's solid and it's not moving, but you run along the line and you've got this series of changes constantly going. That's just my humble opinion. Generally, I've got to say, with all the events going on in the world, including our contribution to world affairs as a family, a Keshe Foundation family, I can't help but feel absolutely happy all the time. Try as I will to get miserable, by focusing on things that really should disturb me, because there's a lot of bad news flying around if you just bother reading the news in the media. But I can't, it just won't stick, because I'm so easily now starting to see that the greater things that are behind the scenes, the invisible things. We were talking earlier about old Gans containers that still got the fields. It's invisible. Alex built his swimming pool and emptied the water out because the fields were in the swimming pool, and it didn't matter. It's the invisible things, and I'm sort of tuning into that and feeling really, really good. I'm smiling all the time. I was a grumpy sort of person due to my work and the stresses of it, but now I'm a changed man. I'm a happier person, and it seems nature, like we've recently been talking about birds a lot, and they're flocking around in my garden. They're absolutely, they seem to take turns. There's almost like a schedule, you get one lot of bigger birds coming, and then they leave and they take what they want. And then another set of birds, tiny little birds, will come in and they'll have a go. And they come really close. Whereas before, as soon as the door opened or as soon as you moved toward, they would fly, you know, immediately in fear. It may be just me, but I'm seeing that they stand their ground. They look at you now and they're actually looking like they're understanding what you're thinking. And I'm certainly smiling back. And, you know, I think the world is on the verge of something very special. We're in the midst of it. And if changes are going to happen, I don't see disasters and I don't see calamities, whatever. What does Rick say? On-time delivery. You know, we're just starting.
In time delivery. Yeah.
Thank you, Rick.
JIT is the official.
Right. So the plasma technology has arrived just in time for us to utilize it. It probably wasn't even necessary in previous generations up until now, but for some reason, some would say because the end of the world or the universe and the cosmic, but it's just in time that we're moving into this phase of our existence because we're riding upon the earth and she's ready and we're ready and it can't be stopped because it is just a natural process. And that's my opinion. I won't keep everybody.
I think it's wonderful, and I thank you for the great testimonial and the tips for regarding replacing the sun cream. I didn't want to fearmonger or anything, you know. I believe it's all our reactions, how we react to different things. If you consider, for example, a torrential rain, in some respect, yes, there's lots of changes coming in, or a forest fire. It's a huge change in the environment compared to the previous lush forest. But after some time, there will be much more vegetation because of the caustic that's generated through the fire, and the nature is revitalized. So,
Lawrence, I don't know if you heard, but Caroline was talking earlier this morning, actually my time, about a phenomenon in Italy that occurred on a bright sunny day where a tiny little rain shower was falling on the road, and it was only a metre or two wide, and there were no clouds, and there was no sprinkler systems operating nearby or anything, and it was so obvious people were calling it a miracle in their Italian language. They were all sort of crowding around and putting their hands into this very small rain shower. Now, what's going on there? You know, we say that reactors create matter out of the air. Well, maybe that's a sign that that the plasma is kicking in, and we're starting to see these what would be considered strange, miraculous occurrences, because we're actually changing the structure of the atmosphere of the planet, and it's inevitable that things that, you know, seem impossible will become possible and are becoming visible now to us in the level that we can see and feel.
Yes. You know those statues that are in the churches that sometimes cry when people are praying to them?
Yeah.
You know, these which are considered miracles. I think
Yeah.
the painter or the creator of those statues had understanding of plasmatic knowledge, and he used Gans for painting those faces or whatever. And whenever a certain strength of fields emanated from the people coming into the church and, you know, giving off good magnetic fields and prayers, reached those little statues, they, for example, started dripping blood, like we do with the hemoglobin creating.
Yeah, well, most of them were Gans, all right, but the Gans they used was olive oil, and they impregnated or had a little chamber inside the wood with the olive oil. And olive oil at room temperature is semi-solid, and when it's sort of cool in the church, or it won't flow. But if you get a bunch of people in there, that changes the conditions of the atmosphere. It warms up the whole church and so on. Then that olive oil will start to flow at certain times, maybe at certain times of the year, or certain times when everybody gets together in the church or whatever. So they have discovered that most, if not all, of those phenomena are actually fake in terms of that it was not blood, except a few of them were blood, but they were of the local people that were.
Okay, I didn't want to go into this religious way.
Yeah, I don't want to get into it either, because
I just wanted to say that
a few months ago I got into it quite deeply and discovered that it was virtually all fake. There's only one that's actually considered not fake by the Catholic Church itself, and all the other ones, they consider them fake, and even the one they don't consider fake is pretty questionable. So
funny about that, isn't it? Everyone else is fake except us, and we're really big. It's a great money spinner to have a crying statue or a.
Well, it's money, but it's also it solidifies the faith of the congregation. This is the whole thing about it, and it hooks them, and it hooks them for generations and generations, because they always talk about, oh, that miracle that happened back in 1632. And my grandmother's grandmother's grandfather was there for that, and it was so amazing and so on.
You remember the guys a few thousand years ago when they came down from the hill and saw all the people running around the golden bull, and then they said you shouldn't make idols and all kinds of other things to pray to, because God is everywhere and you shouldn't make pictures of him and stuff like this.
Right.
I think the knowledge of plasmatic interactions, just like Mr. Keshe explained with the Iranian candles some times ago, when one candle was able to heat the whole bath. The understanding of plasmatic interactions has already been with people for quite a long time, but it was only a selected few who understand and operated with this knowledge, because it's the horn of plenty, or whatever you may call it. It's the understanding of it's that kind of happiness that you've been talking about earlier, that you have everything. Whatever may happen is good, and when you're happy like this, it's much harder to control you and make you do things and stuff like that. So,
well, how sad for them, Lawrence. Hey, for those that have been in the controlling business for thousands of years, because it's tough. We're happy. We're getting happier by the moment and free, and we'll soon be traveling anywhere we like, in seconds, landing on their front lawn and waving, while they're still trying to tell us that we can't do that without a passport, or getting shot by somebody, or they're going to build a bigger wall, or whatever. We just
imagine if you used to be a slave driver and part of the higher echelon of society that was keeping slaves and so on, and you get into our new society where we elevate ourselves from beyond the slave stage, and so you still have the slave drivers, but they don't have any slaves to drive except maybe robots or something. It's going to be very frustrating for them to go through this phase. They'll have to elevate themselves to whatever's beyond a slave driver, wherever a slave driver elevates to because it'll be a job category that gets sort of obsolete, and perhaps we'll have to find a new home for old slave drivers. We'll put them on an island somewhere where they can all sort of boss each other around or something.
They can supervise the robots or something, you know, instead of people, living beings. They can stand around marshalling the, you know, the robots, sending them out. The robots are already going to go anyway, but at least they're ticking it off, you know, and gives them something to do.
Gives them something to do, that's right. Keeps them out of trouble.
Keeps them out of trouble.
So, yeah, this is one of the
all the
pointy
history
issues of the modern world that we'll have to be facing.
All the history, all the evolution that we are having fits into this just-in-time system. It's even the way people have been behaving or are behaving with each other is a form of plasmatic balancing. It's all within that big spiral, and when, you know, at some time we will have to be able to not say thank you, but to forgive those people and our ancestors and everyone
absolutely
involved in all these, you know, childish games of not understanding how the whole system works. And
they showed us, Lawrence, how not to do it, and that's actually a blessing, as Mr. Keshe said. When things get nasty against himself or against the Keshe Foundation, it always turns out better, and people can then make an informed choice about, do we want to do that like we did in the old times, or we've got now a positive choice. And that's the thing. There's some tangible and very practical and beneficial choice we can make to run it the way it's been run by the people that have been running it, or just ignore them, and they've got nothing to do, no power. They only have power if we believe they have power, but they're just like us. They're just absolutely equal to us. Inside even the most evil, there's still a soul. He's just probably going to take a bit longer to loosen up his grip on what he believes is important to him, which is power over others, and getting his picture taken, and having the biggest wedding in the history of the world, and all the other things they do to try and prove to everyone that they're better or they're bigger. But when you don't pay attention to it, or you do pay attention to it, but you don't look at it in that same way as perhaps you used to once upon a time, you can see it for what it is, and it's just all the world's a stage, and all the men and women are merely players. They're all acting. Sometimes they're acting the goat, and sometimes they're acting for the benefit of others. And we can see that the political situation now is becoming very clear that the good intentions of leaders that have realised the error of their ways in the past are moving into a great position of influence over, the ineffective and troublesome and murderous and everything else systems that have been going. And we're watching it on a daily basis, which is why I'm smiling all the time.
It's the plasmatic understanding of you take what you need and nothing else. Whenever someone gives you energy, whatever form it may be, you accept whatever you need, and the rest goes through you.
Yep.
In regards to the things that are or have been done, there's always this move of Aikido. Aikido, this martial art where you use the energy of the opponent to move himself to the ground just by stepping aside.
Yes.
I think that's the art of handling all these situations.
Lawrence?
Yes?
Are you in the private teaching?
Gravity?
The private teaching.
No. But I will do another donation to get into the private teachings. I haven't done it yet. It's private teaching like this right now because we're in a private group. Even though it goes to YouTube, there will be those selected people who will have the inclination of listening and watching it and hearing through it. So I consider everything private in some respect because regarding the marketing noise and all the things that are happening, there's always be those selected few who will be attracted to coming here and to listening to it and to it's just a plasmatic understanding. It's
I like your plasmatic understanding. I like it, and we are waiting for you, my friend.
We're here. We're all in it together.
Thank you.
Thank you.
Yes, indeed. So yes, the so-called private teachings are available to people if they want to become a student of the Keshe Foundation Spaceship Institute, in which case you can partake in discussions of various aspects of the plasma teaching in more detail and kind of a more intimate atmosphere, where there's more sharing and whatnot available, and people already are quite familiar with the format and language that's used and so on, interacting with the same people in the group quite often. So that is available to folks that want to apply at the Keshe Foundation. At the there's several ways to apply as a to get in on the student thing. Several links, that is. I think the kfssi.org site is probably the easiest to access the education portal and apply for. I think it's still €100 a year for access to the previously recorded videos and access to the live teachings that go on pretty much every day through the week and some parts of the weekend as well, and in different languages too. Okay, what else have we got for topic of discussion here? Any more questions?
This is Moshfik again.
Hi, Moshfik.
I do want to get back to what Lawrence was talking about in terms of the reduction of Earth's magnetic field. And it relates to some of the things that we are doing with the reactors. Mr. Keshe has talked about the natural disaster possibilities as well as the increase in the magnetic gravitational field of the planet. So if you think in terms of the gravitational field pressurizing the inner fields and the magnetic field being not less than it used to be, then you have the situation of the inner magnetic field slowing down a bit, so the balance of gravitational and magnetic field, which is the surface of the planet, would expand. And this is one of the things that Lawrence was saying, that there is a possibility of expansion of the surface, and that relates to also the what he called it, the natural disaster situation. So if you expand the Earth slightly, it will cause all sorts of havoc on the surface. So this actually relates very much to what we are thinking of balance of gravitational magnetic field as different layers or cores that we call, and surface being one of the layers, and there are inner ones and the outer ones depending on the balance. So I would be very interested to know about the specific values of the change of these fields. And Lawrence, if you have that information, that would be great, because you can actually calculate certain things based on this rather easily. Now that we understand a little better the balance, how to determine where the balance is. And so some of these are not that, soon we'll be able to do it very easily, and it's not that difficult to understand once you know the what level of balance you are at. So these are some of the things I'm also working on in terms of igniting the plasma. So I mean, that's why these are kind of related in my mind directly. So anyway, I just want to know the actual values of these field changes. And then I think these are useful metric because we don't have right now, as it exists, ways to measure these, the fields of various types that we have in our reactors. Although there are some clues based on the strengths of the various ganses, and one can isolate certain fields using that method. But if there is another data point from the magnetic and the gravitational field of the planet, then that would be very useful.
There's the YouTube guy, Ben Davidson, Suspicious Observers. He has lots of videos, and also he has a whole long presentation, hour-long presentation about exactly this topic. But as Mr. Keshe explained, the density of, for example, the magnetic fields or the field strength is also changing due to the day and night cycle. When the sun's pressure is high during the day, the fields are much denser than during the night when the fields are much looser when there's no sun. So there's an overall change which is measured by these scientific guys, as we currently know, but we also need to consider the natural cycles, like we explained with earlier, also with the planets, but mostly with the day and night cycle, because that's the one that we're experiencing as the most intense. And if you Google or search for Earth's magnetic field strengths, 1980s, then there are charts that show that it's declining. I will search for something on Google that has the exact result that I want to show you. Earth's magnetic field strength 1980-2017. If you put in this, you will have search for Google images, and there you will have different charts that show how much it has changed.
Thank you, Lawrence.
You're welcome.
Just a thought, if the magnetical and gravitational fields of the Earth are changing radically as they're saying, and just at the same time as we are aspiring to fly, to position ourselves off planet closely or distantly, isn't it amazing that maybe those, because of everybody's or enough people's intentions, these things are happening to assist, and maybe other entities from other places also are assisting in the process, so that what were myths and legends, like Denny and I were talking about flying carpets, and Rick and so on last week, we're seeing now that they're not myths and legends if the intentions, even if it was only a few then, but now many people are wishing or intending or developing systems to travel freely. Why wouldn't the universe provide and the Earth provide the necessary conditions for us to do that with ease and not with any struggle, but just relax into it?
Sounds fair, Doug. We have Renee here, who's provided this picture and mentions he has a technical question about the maggrav and this strange effect. He says that he can run a small LED together with a glow lamp on the same outlet, same wire, so that DC and AC are mixing. This should be impossible, he says, but it works on the maggrav situation here. I believe we've seen this before. This is one of the first things about the plasma or the nano coating that was demonstrated by Armin quite some time ago, that it's a combination of AC and DC is available and measurable from the nano coating itself. So it's entirely possible to have both on the same wire. You can have different frequencies or different conditions. It says the LED and the glow lamp are connected to the earth and neutral wire. I do not touch the hot wire, and the earth is disconnected before the maggrav. So the earth wire acts like an antenna. And for some reason, the field did not collapse when I extract the energy. Yeah, well, I'm not sure what you got there. If it's between the earth and neutral wire, you will get some transient voltages going on there normally. So I'm not sure.
So Rick, I like to explain a little bit more about this.
Sure.
About this effect. So maybe you can publish the second picture from the chat that I placed there, where we can see more. Okay, thank you. So I have to tell you, about 2 or 3 months ago, I got the info from a teaching that we should disconnect the earth wire on the load side. So I made this, and about a week ago, when I plug in some resistors and stuff like that to do some measurements, I get shocked when I touch the earth, and I have no explanation for this, and I don't know where this energy which builds up in this wire comes from, and then I tried to test it, and I can measure a voltage between this earth wire and the neutral wire. The voltage is about 110 volts, so it's very high, I think. And when I connect this glow lamp, I realized that the energy did not collapse. So in a form of way, so I don't know, there is an energy that is transferred to this wire, which acts, I think, like an antenna, and I can get usable current from it. And you can see there's a LED lamp which should only run on DC, connected together with the glow lamp, and both works.
Can I give a...
Because if I connect a red LED lamp, the glow lamp did not work. So it is only happening when the green LED is in display. So
Can I give you a simple explanation?
Yeah, please.
What you have here, you have a long cable. I don't know how many meters it is, but it has some meters.
Yeah.
And then you have 3 parallel wires.
Yeah.
In between there is insulation. So now this green wire is not connected at any part.
No, it's not connected.
So now what happens? You have a power line which has a voltage between earth and live. You have 230 volts or whatever that you can measure. If you measure between a plain earth and the live, it should be about 230 volts AC.
Yeah.
And now you have a long wire which is parallel and it's separated by a thin plastic insulator. And you touched with your hand here on this point, or you can measure here a voltage. So now you have to know from physics or from electronic components that if you have 2 pieces of metal of a certain surface which are separated by an insulator in between, it's called a capacitor. So 2 parallel wires which are insulated are themselves a capacitor. Not a very high value. It may have a few nanofarads, for instance. But if they are nano-coated, in that case, its surface, the surface is increasing, so capacity also increasing. And if you connect yourself between Earth and the live 230 volts wire with a capacitor, in that case, you still can observe a voltage. Now you connected yourself by your own body resistance, so you got a shock. I think it's due to the capacitance between the 2 parallel wires. I worked in electronics for many years. It was my hobby too, since I was a kid. And whenever I wasn't able to purchase a few picofarads capacitor, in that case, I just took 2 telephone wires and I just twisted them together. And I cut them at a certain shape, a certain length, and I had already a capacitor just by twisting together 2 wires. What you could do, if you have a capacitor meter, a measuring device for LRC, which can measure capacity, you can unplug everything from there, from the power source. And once it is unplugged, try to measure the capacity between not that one, the live wire and the earth wire. So try to measure here the capacity. How much is the capacity in between when all is plugged out? So that may be a clue. You see, it acts like an antenna. Yes, of course, there is also some combined inductance. Whatever has a length, it has an inductance. Whatever has a 2 metals, 2 conductors separated by an insulator, a capacity. And for that small light to light up, it doesn't need too much current. It's just a few microamperes.
So I know what you mean, but I think the field collapses if you collect constant current from it. So, And if the field did not collapse, there must be energy flowing to this wire. Maybe it's because of the nano coating. I have not checked if the nano coating goes on, but I think that's maybe a good idea to think about the nano coating.
You can exclude that possibility, or you can confirm if you get the same kind of cable, the same length, and you just measure the capacity between the brown and the green, yellow wires, and do the same for the wire which you have already in the system, which supposedly is already nano-coated, to see if there is any difference. Just ideas about what we can measure. You see, you have electric current, matter state phenomenon that you can measure it. You measure the voltage, you lit up an electric flash lamp. So what is producing it can be measured. By the way, you have a very nice voltmeter there.
But the voltmeter shows only shit. So this voltmeter, if I connect it to these two wires, as you can see on the picture, for some reason it shows only the 26.35 in every measurement range that I.
That is correct. That is correct, and that occurs because of the internal resistance of your voltmeter. So you can have an open circuit voltage of 1000 volts, and when you connect your voltmeter, it goes down to 1 volt only. It means you have a limited current. If you have a high resistance or a high, reactance, which is limiting the current very much. Because of the limited current, the voltage will drop over the internal resistance of the measuring instrument. So the instrument itself has an internal resistance. If you understand the Ohm's law and the two theorems of Kirchhoff, you know the basics for understanding these voltage measurements. Three simple things which are needed to understand what you are doing in circuits. Ohm's law and the two theorems of Kirchhoff.
Yeah, I know all this stuff from the past, but it did not help me much when I want to measure the megas.
Yeah, I learned about that trick with the voltmeter while I was in the school, in the 10th class. We had an electronics lab, and one of our student colleagues called us, come on, let's see something interesting. So he had a power supply, a big one, and he tried to measure with its analog voltmeter, and on every scale it was showing just a small deviation. So you know these analog meters, they had a needle, they had a scale, and you get here a 0, and you had a knob where you could change the limit, 100 millivolts, 1 volt for the 10 volts, or 100 volts, 10,000 volts, and so on. And when he measured the output of the power source, he got a very small reading on all the scales. So if this was the 0, he got a small movement of the needle, just a very tiny one. Does not matter on which scale he was measuring. And that was because the voltmeter itself, it has an internal resistance inside, which is very high. It's of the order of hundreds of kilovolts. But the entire circuit had a much higher resistance of order of megohms. It had a bad contact somewhere. And you can see that this internal resistance took all the power from the very much limited current which came.
Yeah, I think in this case, maybe the power, the DC power, maybe comes from the plasma capacitors that are connected on the input of the MAGRF system between the hot wire and the neutral.
Hold on, what are you measuring there? AC or DC?
Yeah, it's no matter. You can measure DC or you can switch to AC. It only shows the 26.35 volts. So
because I see if you put an LED here, this green light, I suppose it's an LED.
Yeah, yeah.
In that case, already you put a diode, which is rectifying. So you will get DC from the AC. But can you measure the DC even without the... Can you measure DC without the LED in the circuit?
If I measure without the LED, I got about 50 volts AC, and I cannot measure a DC voltage.
That's correct. That's correct. So you have an AC there due to the capacitance between the wires, and you have DC only when you rectify that AC by the diode, which it's a light emitting diode in our case. So actually the equivalent circuit of this one would be the following. You have a live, somewhere you have a neutral, and you have an earth, not here. You have the live is somewhere connected to the earth, very remote at the power station. So you have here your wires of a certain length, and now you have that green yellow wire which is parallel with this one, with the live wire, and on a certain length, let's say 2 meters, it creates a certain capacitance. It's like a capacity here. So you are connected through the live wire through a capacitor, and because your feet are earthed, when you are holding the wire, you will feel a tiny current of a pretty high voltage there. But the current is limited to a small value, which is not harmful. So the current would go in this way from the generator, the live wire, then through the capacitance of your the parallel wires, body, and go back to here. Now it's interesting why you have here the light when you connect these two together. You put that gleam light or whatever here, and why you have the light. This is the big question, and it becomes more interesting.
Yeah, I know.
Because
so
it's again easy. You have a resonance circuit. You have a closed loop resonance circuit. Okay, it's fine. You have an antenna, you have a receiver there.
Yeah.
It's something similar to what one of my friends did when I was a kid.
But where?
He was living near.
Flowing to. That's the big question. The current has to flow from, I think, from the antenna to the neutral, and the neutral is connected to the ground in the power station or in my house, for example. So I got a flow of current between this antenna and the earth.
Mm-hmm.
And
it's interesting.
Yeah, this is now I have to search for a way how I can amplify this this current because it's, as I said, the field did not collapse. And
you're harvesting something and you want to increase it. You see, I had a friend who was living near the high power lines or near the electric train. I don't remember what, but he had high voltage lines, power lines near his house. And he put an antenna for radio, but a 40 meters long wire antenna, well insulated at the ends with such ceramic insulators. And he wanted to use for a radio antenna. But once he had the idea to connect that by a small lamp to the earth. And he had a light on that one. You see, just a small incandescent 4.5 volts bulb lamp with wolfram, like used in the old torches, flashlights. So he had the day and night light by the power which he was capturing from the fields around the high voltage power line by using a sufficiently long wire antenna. Interesting things happen in AC. So anyway, it's very interesting what you have shown. I just wanted to give some hints and tips of what could be there according to the actual physics. And if you can replicate the same without your maglev unit, just with the wires of the same length, in that case, it's just common sense physics phenomena. But if you can do that only by that nano-coated wire, in that case, you discovered something extra.
Yeah, there needs to be some more testing on that for sure.
So you can compare, you repeat a part of the circuit, and you don't add the other part, and you see which part of the complexity is producing that thing. Now you have a complex circuit with many things, so try to remove some parts of it until the phenomena still persists. But instead of taking it apart, build another one. Yes?
Would you please explain how the light is emitted when we use the simple CO2 box? Because Mr. Keshe always says we should put up a resistive load to connect the plates. And when we put a LED between the two plates, we also, at sometimes when it's working well, we get the light. Are those plates also just simple capacitors, long wires that create a current from the environment? Or is maybe this resistive load just an explanation to create a plasmatic circuit where the nano feeds the material and like this creates a plasmatic current that we really need for the capturing of the Ganses?
Yeah, the Gans capturing is one thing, and the voltage which appears between two different metals which are immersed into salt water, it's a different thing. So you can take a piece of copper wire, a piece of iron or zinc, and you just immerse them into the salt water and you measure a voltage between.
I'm very sorry to interrupt. I just, got into the meeting. Can you?
Hi, Arman.
Hi, how are you guys? Can you show me what you've done?
In this picture you're talking about, Armin?
Yes.
Okay, well, let's get it re-explained. That would be a good idea then. Maybe Renee can explain again what the hookup is here, what the setup.
Yeah. Okay. So what I did, I disconnected the earth wire from the maglev load side. So on the load side, I connected some resistors and motors and stuff like that are running 24/7. And this black cable that you can see in the picture is in parallel with these devices on the load side. And
can you show me the picture, or can you show me what you done?
Sorry, I did not hear you at the moment.
Can you show me what you done? Can you show me the full picture, what you done? I can see the LED, but I don't see the setup.
So the full picture, yeah, I can show you a picture of the lab and can explain where the wiring, which wiring I've done.
Where is the other end of the wires?
Yeah, I have to look for a picture. One moment, please. So I have to look for a picture, but what? So you want to see the whole system?
Correct.
Whole system. Sure. So actually, I go through the pictures. Where is a photo from the whole lab? So. I have thousands of pictures. So here it is, on the top you can see, or I don't know, can you see a picture now?
Yes.
Yeah. Here on this shelf, I have the Magnesium system that is powering this small flat. And here is the power line that comes through to the Magnesium. So this is the line in, for example. And here that you can not see on the picture, I've disconnected the earth. So here on the outside, on the load side, I connected a camera, and these wires that I coming down, I've connected a fridge, for example, these lights and so on to power up this workplace. So this is you can see that there are many cables, and as it was mentioned before, maybe there is a capacitive effect or something like that. But I cannot show you a picture where you can see the black wire which is coming from the load side. So I have not make this picture, but I can.
Let me understand. So you had a life going to your maggraph, correct? Your plus.
Yes.
You disconnect your minus from the earth, actually, and you connected the earth.
I didn't understand your question.
You disconnected your minus, correct? And you connected your minus to the earth.
So there are three wires: the blue, the brown, and the green yellow. And I disconnected the green yellow. I disconnected the earth.
You disconnected totally the earth.
Yes.
So
the earth is represented in here. I'm connected in this to the power line that goes into the maggraph. The earth is connected, but after the maggraph, the earth is not connected to the input side. You know.
Okay. So how you light all this lightning then?
Sorry.
The lights that I see, you power from your maggraph?
Yes.
But you connected to the earth?
Yes, I connected to the earth, and I use the neutral for powering up these two lights. And as I understand, as I know, the neutral that I use is connected to the earth in the installation, the electrical installation. So I got a current, a usable current from this earth, from the load side, which acts like an antenna to the potential of the real earth that is connected with the neutral together.
Let me annotate. Okay. Here's you have your. Here's you have a wire, correct? It has a two, one earth, and one phase, correct? This is plus, this is minus. So this comes to the mag graph. And after mag graph, you disconnected your earth, but connected from your house, meaning from the ground. You took the earth and connected, correct?
I'm sorry, I don't understand.
No, what I'm saying, where are you taking your ground? It's not from the panel, correct? It's from the, you just put it through your house or connected any earth, which is connected to the earth, any pipe, correct? How you connect, how you take your minus and connect to the lights?
So actually, I have no idea what you mean when you say minus.
Okay, you have a plus and you have a minus. Huh?
The common wire, you mean, right?
Yeah.
The common, the plus and the common.
So maybe if I could, can I make a drawing? I think.
Yes, correct. Can you do that, please?
Yes. Okay. So I have.
Maybe we want to start with a new whiteboard.
Yes.
Okay, so you can do a screen share screen and select the whiteboard. Do you see it there? It should be in when you click share screen. Yeah, there you go.
Okay, so.
Armin, there's a lot of noise in your microphone. Maybe you can mute when you're not speaking.
Yeah.
So, okay, this is my power from the grid, and with these two wires, I go in the mag-graph system, and in the mag-graph system, I connected four plasma capacitors this way. So I use the neutral and I use the hot wire, and I got four of these guys. So, and here So here's the load and here is the earth connection, but it's not connected. So the live and the neutral goes into the maggraph. They are connected in this configuration, and this is only a wire which is in parallel with these two wires, and the length of this wire is about I think maybe, yeah, it has to be 6 to 10 meters. So, and on the photo that you can see, I use these. So this is the black wire from the picture, and the connection of the lamp is between these two. So here is the LED lamp. And the glow lamp.
May I ask, on the entry part, the green-yellow wire,
yes,
is it connected to the plug? So is it earthed on the other end?
This one?
On left side.
On the left side? Yes, this is connected with the earth.
Oh, that explains a lot. Thank you.
And on the other side, there is no connection between this and this. As I say, I connected this, disconnect this wire.
Look, it doesn't matter. Now I understand what you did. It's the same thing what government is doing. When they produce a lifeline, you know, it's from the generator, huh? They bring it to the station, one wire, and then from station, they connect it to the earth and they sell us as electricity. This is how it's done. You can take the hot wire and, you know, put a piece of metal into the ground and connect your neutral, and you can have the whole light and you can use it. That's actually you're stealing the energy from the government. that's the truth.
Really?
Yeah. Oh, it's almost because he's getting it not from the live, not from the neutral, but from the ground wire.
Yeah, but
so why I don't understand why this works.
Because you just connect it to the earth. This is the same thing government is doing. You know, when they create, from the power station, they bring only one wire into the other station, which they connect to the earth. Then they, from that point on, it's two wires. So that's why. So you just bypass their neutral.
Don't returning a station generator. You put direct in ground. It's not stealing. System stealing from you.
I know that. That's what they call it, stealing.
So now here you have a long wire of 6 to 10 meters, which one end is grounded, and it's all parallel with your live wire, which has power on it. So actually it creates once an antenna, or it will create some inductance, but also it creates a virtual capacity between the two wires. And when you connect this free end, this we call a free end, when you connect it through your hand or through a gleam lamp to the earth, a small current will pass through, even through that virtual capacitance which is created between two parallel wires. because a capacitor is nothing else than two pieces of metal or conductive material with some insulator in between. And if it's just a wire, a pair of wires, but enough length, in that case, the capacity can be of a couple of, let's say, 50 to 100 nanofarads, which is pretty enough to get enough current to let you feel a shock. So now this should work even without the maglev connected on the system, I suppose.
Yes.
So you can replicate it with all the wires without the maglev, and you can repeat the measurement to confirm whether it's due to the maglev or due to the classical physics.
Oh, that sounds good. I will try this. So maybe, but you don't say that this is a tutorial on how to steal energy.
No, no, no. It would be still if you would take from the live and Earth. So this would be a steal. If you would take it here, and some old meters may not spin, but the modern meters of Europe, where people invented how to steal current since long time ago, they already are made in a way that they still measure if you try to do that kind. Maybe
some people get power between the Earth and the ground, between the Earth and the neutral wire, because sometimes you can get transient voltages between the two, because
so here in Europe,
and so
yeah,
that's not recommended to do. It's actually illegal to tie into the Earth wire. The Earth wire is there to ground any transient voltages that get into the system, and it's not there to tie in to get power out of and so on, because if you get a transient voltage coming from the neutral down the line, you can get electrocuted from the Earth line that you've got hooked up trying to get power out of it and so on. And that's the reason why they don't allow people to hook up to the Earth line. You're not supposed to use it to try to get power out of, or to use it for to go between Earth and the power or line.
Yeah. Not to say that you are killing earthworms if you do that.
Yeah, probably. Or at least give them a big thrill. Good point, Shandor. Okay, so I think we're kind of getting a little far afield here, but it's good to explain in an ordinary way what this phenomena is. I don't think it's a special plasma phenomena that's occurring here. Although this idea of alternating current and direct current occurring at the same time is a valid idea, and it's part of the measurements as Armin has measured in the early days about 5 years ago, measuring the nano layers and showing on a voltmeter that you can get both AC and DC voltage from the nano coating, and from a copper wire, basically nano coated.
Actually, you get AC when you have, let me annotate. If you put two different materials, matter and a Gans, and a nanomaterial, then you measure AC. If you put here Gans, but let's say this is copper, this is zinc. If you put it like close together, like tiny, then you can measure AC.
Now, regarding the measurement of AC, you have to make sure, is it only AC or just the voltmeter on the AC scale is measuring the DC?
No, I understand, but...
Yeah. So the easy way is to put in series with your voltmeter a capacitor, which will not allow DC to go through, but it will allow AC. So this is called filtering. You can separate the DC component by a capacitor. And this applies also when people are measuring the assumed capacity of the plasma capacitors, which are also plasma batteries, and they make the instrument crazy by adding a DC voltage to the instrument, which is not supposed to handle that. A separating capacitor at the end of the measuring probe, it's just fine. Or you can measure voltages with oscilloscope. That's the best. Of course, you can get both AC, DC. We have seen so many times with oscilloscope measurements as well.
Are we thinking now in terms of the nanolayers on the copper or any of the material that we created with the nanolayers? Because we have a superconductor within the layers and the super resistor between the layers. So we have a super capacitor within each of the layers. And on the horizontal side, we have a constant resonator in that particular layer. And when we touch with when we connect the wire to the nano coating, we are touching the uppermost layer and creating there also a kind of connection with the metal and the nano, the capacitor and the superconductor, the constantly resonating thing at the same time. And when we create the circuit with the other metal, we are creating a plasmatic feeding. We are, just like Caroline said yesterday, we are giving away the first MAGRAV unit. It's the same with the connecting of the resistive load or the LED between the plates. It's the giving away of part of the plasma to create the gradient, the feeding. It's the
okay. Do me a favor. If you have a let's say a plate and it's totally nano coated, when you measure, just try it at home. When you measure, you're going to measure a small voltage. (0.2) until 100 millivolts, you're going to measure it. But a minute you touch the matter, this jumps up to, 0. I measured it 5, half a volt.
But we're measuring with matter state. We're measuring with matter state because the volt.
No, one wire is touching nano, one, the wire is touching, the metal. You crush the layers.
I mean that the voltmeter and the probe that we're using is in the matter state. So basically the plasma is feeding the voltmeter the matter state because
no,
the condition.
No, when you measure only the nano layer, the interaction, only the layer that it's nano coated. But a minute you touch it's totality you measure. That's why the voltages jump so high. Because if you understand, the matter still in plasma state, but more compact. Now you measure all this, atomic structure, which this plate is made of. So all the interaction in totality. Because they interact, huh? This is higher, this is lower. That's what you're measuring it. This is higher, 1 minute. I cannot annotate, my God. What's wrong? Oh, maybe no. This is higher, this is lower. So they interact everything. Now you measure totality. That's why the voltage jumps so high. Matter is still a plasma.
Stronger feeds the weaker. Nano state is stronger and feeds the matter state. And if we use
Correct. Now you measure the totality of it, the interaction of total surface.
yes, and the voltage
Inner and outer. That's why it jumps so high. If you go and measure it from, let's say, if this is the wire, if you cut your wire and just with the probe, just touch right in the middle and right on top, you will see a small wire, like very small piece. It will give you the same.
yes.
So, but then change it. You have this wire. Now you have your Gans. Now you put one metal and another metal on top of it. But don't roll it. Just you have to bring and just to the edge, to the edge. Don't roll, you know, some people, they roll it. No. If you put copper, just bring it here. And then you continue from zinc to here. Inside is your nano-coated and your Gans. Then you can measure AC. Because now the interaction, the ingredient that you're talking, AC is creating in a matter state, huh? But because of copper, it's lower than zinc. So you have a gradient. That's why you're measuring AC. Otherwise, you're only going to measure DC if you have a Gans and nanomaterial. You understood what I said, no?
If you're asking me, I think yes. I think.
This is Moshfek. I have a question. Instead of putting copper and zinc, if I put just brass, what happens?
Brass?
Yeah, which is a combination of copper and zinc.
Try.
It should do the same.
Try it, yes. More or less, yes, but definitely it's two metal different.
Yes.
Mediums, huh?
Thing about brass is that the metals are so fused together. I don't know if you can get the separation for the gradient with it. I was thinking about brass today that way. I mean, it's got the zinc and copper. You would think nano-coated brass itself should be able to produce a good Gans just by nano-coating the brass and putting it in saltwater solution. But I don't think that's the case.
You can do different things too. Look, law of the plasma. higher, fits lower. If you have a Gans, bring a dry Gans and put the same matter. Like dust. Mix it with Gans. Create interaction. You compact, let's say, your battery with Gans and with powder of matter. You don't need to roll it. Different Gans combination, different matter combination, it gives you interaction. The flow. The same thing, you're measuring a wire. The nano part and the matter part. Then you see it jumps up to 5 volts, 0.5, half a volt sometimes. You measure a totality of the interaction. That's why it's so high. But when you measure nano only, you're just measuring the surface. Interaction of the whatever it absorbs and whatever it gives you. But the same nano, energy transfers to the matter too. The atomic structure of the matter. So they interact. You create the wind.
So that brings the question of matter state vibration. So how do you calculate the frequency of the matter state vibration?
You don't need the matter state vibration. That's the only thing you can vibrate if you cut the magnet through the copper wires and you can vibrate the electron. That's only vibration you do, and you call it electricity. When you bring the life and connect it to with the earth, so you have your electricity. Huh? The life wire comes from your house. Just dig, get the metal, 1/2 meter metal rod, and just stick it into the ground. This life wire and earth, you can have all the electricity. Because that's what the government is doing.
It's kind of like the area of like 60 hertz versus 50 hertz. Does aluminum create the same electron vibration because the spacing is different in case of aluminum versus, let's say, copper.
No, if you have your generator, it's only copper wires, huh? You move the magnets. Inside the coils. Let me draw different. Here, this is the coils. So it rotates. You create the vibration, electron vibration in a copper. That's the only thing you do.
Yes, I understand the vibration part, yes, but the frequency of vibration, does it depend on the material structure? Because each material has its own particular spacing, or the outer shell of the electron orbit.
Yes, definitely.
Has different energetic states, right?
Yes. Different gradients.
Yes. So the frequency should be different because of the different radius and the outer shell binding of the electrons.
Of course.
So possibly there is, I'm not sure this relates to getting the frequency right, but the outer shell structure, in the subshells of various atoms, you can perhaps get an idea of what the frequency would be from that. But I don't know. I mean, is there any way of determining what frequency that a particular metal, the electron in a particular metal would do? Or is there a way to find out what the spacing would be? And I mean, whether it's through an instrument or some other measurement means of measurement. I'm just curious.
Well, I would suggest to think in how the Earth's magnetic field is drawn. You know, we have these magnetic field lines and the gravitational lines in the middle. I think the magnetic is how we should think in terms of electrons, of how the neutron expresses its electron. The electron is like the magnetic field lines of the Earth, and what we consider protons is the gravitational in the hills and the valleys. And if we consider these, you know, like stripes, then it's much easier to think of in terms of plasmatic strength than when we consider the subshells and the different electron configurations as we used to in physics and chemistry up until now.
Good point. Thank you very much.
Everything in matter cut the line of magnetic field of Earth. Mr. Arman, I have one question for you. Is possible?
Definitely. Yes, of course.
Between the nano layers, I know I have all the spectrum of field, every field of plasma, but in the, for example, plastic or one matter, no matter, how to say, B component, no, like a brass, like a, I don't know, Gans of CH3 or CO2. Nano layer, when you have nano layer, what atom it's suspends, no, from matter outside? hydrogen is apart, carbon is apart, or it's between, it's colligate, CH, bone, nano, or like an egg. The nano structure.
Can you explain it one more time? Because maybe you draw it, what you want to say?
Yes, sure. I have a reactor for nano coating something. It's not important what, or it's important. Nano coat plastic, bottle of plastic. I have a structure of this plastic. It's made from carbon, hydrogen in different way.
Okay.
When you make nano layer of plastic, of this material, what atom it's suspended? It's first, it's closer carbon, and after it's hydrogen up. How to layering this nano? Reference, it's matter, no? When you take.
Can someone clean the board, please? So you're saying this is your box and you put some material to nano coat, correct?
Or only hydroxide of sodium or potassium and water, hot water.
Okay. So how the process is? What is the process?
No process. How to? It's a create nano layer inside the box, in the box.
Okay.
What it's this nano layer? Natrium OH and water.
Look what you have over here. You have a salt and you have a hydrogen. When you put hot water, it creates so much energy, meaning so much heat, that the first molecular atomic structure from the plate, you pull it. It's like a vacuum. A minute hot water touches the caustic, this is the reaction. You see everything boils up. In that minute, you create enough heat that you can separate first layers of atomic structure. And after, when you leave it in the condition, still the process is going. That's why we leave it in, let's say, 24 hours or 2 days or 3 days in a box full of water, and you're not changing the condition. After when you dump the water, so still you leave it in a caustic condition, the environment, still the process is going. Because when the first 2 layers it's separated, it's a plasmatically they pull the other atomic structure. So that's why you create the gap. That's why you can measure, when you nanocoat the material, you can measure the interaction. The voltage, small voltage that you are measuring, it's the interaction between this with this, this with this. Do the different color. This one, this one, the whole layers and layers and layers. So this whole interaction that you are measuring it when you touch, where it comes from, where this energy comes from. If you put it on a matter, you're measuring it 0. A minute you nano-coat it because you created already the separation. So you're measuring it some voltages. But then you touch the matter side, you crush the layers and touch the matter. Now you're measuring it totality. Because now they interact with the matter state too. Now this interaction, it goes here too. The whole structure. That's why you measure it higher. Try it.
Can I add it layer of nano different because I change environment in the box? Like a mirror. You have a surface of matter and you take from matter in atom of I don't know if it's correctly say atom of this matter. It's energy. It's
you separate. You create enough heat. What is heat?
Yes.
It's a magnetic gravitational field.
My question, I understand this, but my question is, what is this atom? What is it evaporate in the when you have iron? I understand it's atom of iron. It's gapping this. You have plastic. You have bond of carbon and hydrogen. You have a piece of, I don't know, another material, copper. You have this atom of copper. No? My question is, it's possible. It's possible. It's necessary regarding in what nano layer create. It's important, or it's important energy between the gap in layer, between the layers.
Energy between the layers.
Okay, thank you very much.
Okay.
It's possible, Rick.
Go ahead.
It's possible making another little question from Gans, how to make Gans. Because I don't know how to look in the reactor of, for example, magnesium or in the nano magnesium, no? Nano coating magnesium and another plate of magnesium in white, I say. What's obtained if magnet of this field between two plates, different in the mass atomic or oxide, because always you have two components. You have oxide of magnesium, for example. You have a field create between. I know it's a package of field, but when you have copper and zinc, nano copper and zinc, you create the carbon field. You have CO2, carbon and oxygen too, and also you have zinc because pulling from zinc and combine with oxygen. You have two components. You have Gans of something and the field of something. It's interaction between field and another material. Changing position, you create another field, another interaction, another material. In chat, it's made one question. I have salt water with salt of magnesium, two plate, one magnesium in white and another nano-coat magnesium. What it is inside? What Gans I produce?
Magnesium Gans.
Okay, thank you very much. Not oxide of magnesium.
The oxide of your magnesium, it's your nano-coat.
Okay, thank you.
As far as I understand, when we're talking about Ganses, we are talking about plasmatic field strengths. And the way these, if we're saying zinc oxide Gans, then we have the zinc strengths and the oxygen strengths combined with each other. It's like a double layer reactor. When we're talking about CH3, then we have the carbon strengths and the 3 hydrogen strengths combined with each other. Again, a double layer reactor. It's the same with the copper oxide. And it's when we see the Ganses, it's the expression of it's basically a small spaceship showing itself in the matter state. They have a boundary. And it's easier for us to think of, but still they are plasmas. So when we're using the material expression of what matter they are consisting of, it's like a walking cane for our minds to be able to operate with these plasmatic field strengths. And regarding the nano layers and the plasmatic.
Armin, could I get you to mute if you're not speaking there? It's very loud. Thank you.
Mr. Keshe always draws this big spiral and then connects the arms of the spiral to points on the spiral with a V. It's the same thing as we have in a nano coating process and later in the CO2 capture kit. The nano layer is, due to its separation and due to the connectedness of the layers, where the atoms are not individuals anymore, but layers like this forming unity, they are much stronger in terms of plasmatic strength than the matter which they originated from. This is what we've been talking about right now, that you can measure a much bigger voltage between the nano and the matter. And when we put the nano plate connected with the matter plate and connected with the resistive load, it's just like the little V's that Mr. Keshe is drawing when he's drawing the big spiral and connecting 2 points on the spiral with each other with a little V. It's always this, we have a plasma, the stronger plasma, in that case, the nano coating, starts feeding the resistive load, and the other metal And like this, the magnetic principle of the nano is increased. And due to the increase of the magnetic principle, the giving of the nano, stronger gravitational fields start flowing in. And the result of those stronger gravitational fields flowing into the nano layer from the outside, from the stronger plasma, are then captured in the salt water in form of Ganses that we then use for different other purposes.
Okay, thank you, Lawrence. Any comments about that? Anybody else want to add to that? Okay. Anybody else have anything they'd like to add, subtract, multiply, or divide with here? Or should we wrap things up? Pretty quiet out there. No more questions? Armin's still available. Do you have any projects you're working on now, Armin? Any particular lines of thought that that we should be aware of? Anything new in your life?
Yeah, I'm setting up Mexico, so I'll show you a few things when I'm done.
Okay, great. Thank you.
I wanted to encourage people to use the empty space of the different Gans capture kits. Empty the kits once you've used them, and then you have lots of fields inside the kits, inside the plastic boxes that you used earlier. And then if you close that box and put it into a bigger box, for example, an empty matter box, you will, in the outer box, experience different fields because the plasma inside the original capture kit will start feeding the surroundings, and the surroundings will, you know, sometime in the early experiments, someone put the CO2 capture kit as it's been working into a bigger box and started collecting water in the outer box. You remember these experiments?
Mm-hmm. Yeah.
It's the same thing. I think we can even combine the different capture kits to create gradients with each other, just like Armin has been explaining with the nano and the metals not wrapped but curled onto each other edge to edge. It's the same principle.
Yeah, good point. Well, Jay says he wants to show a picture of a discovery that I made during the week.
Hello, Rick.
All right. Hi, Jay.
Would that be okay just for a second?
Sure,
yeah.
It's a picture you took, your own picture?
Yeah, it's a picture I made sort of thing. I can't remember how to share screen again, though.
Okay, well, you should have a green share screen button at the bottom of your Zoom.
Yep, I see it now. Just a
And
second.
make sure you have the picture all ready to go so you don't have to share your whole desktop.
Okay. There it is. Happy birthday, Rick.
Well, thank you very much. It's another couple of days, but appreciate the thought there. Thank you very much.
No worries.
It's your birthday, Rick?
On June 2nd, coming up in 3 days, yeah.
Happy birthday.
Yeah, I'll be 49 then. Yeah, right. 39. Actually, I'm 19, going on 16, something like that. The older I get, the younger I think. Okay, well, thank you, Jay. Appreciate that very much. Lawrence, I see you're in twice here now. That's interesting.
Yeah, I don't know. My previous session got hung up. I wanted to further inspire people because you know the Ganses that we are rotating have a stronger effect than the simple Ganses if they're just simply mixed and in a container. And I was pondering a lot about how it works, because it's not only the energy that we're putting in, the kinetic energy by rotating the motors, but it's again the layering, the plasmatic layering, because the Ganses have, due to their material expression, a certain atomic weight. And when we are starting rotating, the centrifuge effect will start layering them according to their strength. I mean, their weights, their gravitational weights. And during the time when they are rotated, they will have, just like we have with the nano layers on the metal, a certain separation, but at the same time also be working in unison. And due to this separation, the empty space in between, and them working as in unison, will they have the stronger effect of plasmatic field flow. And when it's like, because Mr. Keshe said, all these phenomena are happening in nature. They take maybe millions of years once a star is formed. But now the challenge is to replicate this in a smaller scale and create the conditions a bit faster. And when so basically with the rotating motors, because we're at the moment experimenting with those, during the time they are rotating, due to the layering effect of the rotation, we will have a stronger plasmatic gradient than when the motor is turned off. And then those stronger fields are interacting with each other in our motor-based system. So basically, it's like turning up the heat in cooking to get a faster result. The same would happen if we just put Gans balls within each other and waited for some time. But it's just like the nano coating process. It's increasing the magnetic principle of the interaction of the Ganses. And each time when we turn off the motors, we're basically removing the body of from around the soul that we've created. It's just like emptying the bucket in the CO2 kit. We still have the fields inside the CO2 kit. We still have the fields that have been created by the interaction of those matter strength plasmatic fields. Do you agree, Armin? You still there? So basically what I wanted to say is that the way we are producing Ganses is a very, very simple method. And somehow the spaceship should be just as simple and easy, because if we can do it on a very small scale, on the level of the Ganses, because those are also fields expressing themselves in a matter state with different colors and everything. And they're also only plasmatic field strengths combined within each other, then we should be able to do the same thing with the spaceships too, even though it's on a slightly bigger scale.
I have a suggestion. we can take these empty Gans container and get those marbles that Sander was showing before. Just leave them there for a while and let them collect the field, and then put those balls on top of motors. And then you have the high strength fields, just taking the marbles and nothing else. And then you have the field within the motor, within the balls, and you have the rotation that Lawrence is talking about. And then you can generate fields, which is much stronger than what you would just by having the container. And if you have multiple size containers of different Gans material, you can put one inside another and put the ball in the middle, and then you have a composite field as well. So there's all kinds of possibility just using those marbles and using them with a motor. And then you can see create the interactions between them. So that's kind of going in the direction of what Lawrence is talking about, creating simple spaceships. Just use marbles.
I was thinking about in the same lines. Maybe it's the environment that we're using is much more difficult, because when we are born, we are fish, in the water. When the Ganses are born, they are fish in the water, because there's salt water that we capture them with. Maybe if we put the design that we consider spaceships into the water, we will have a much faster expression of interaction in the environment, like we now use in the aerial condition. The spaceship can generate a submarine. Just an idea, or in terms of simplification. Maybe it's more difficult, but you get the point. I mean, like applying the same principle on a little bit bigger scale. Have we been able to capture the interaction of the fields just by having air around? I mean, Peter Salocher had some experiments when he spun his Gans reactors, and he had a sheet of whatever in the middle, and he then started collecting different things in between.
Okay, what do you have there, Shandor? Looks like
So I just plunged the marble with a ball in a net to see how much should I adjust the knot, where to position it. So it's good to try it before. Of course, plates are not yet inside. I'm just testing with plain water.
So it seems to work pretty good.
Yeah, actually with salt water, because it's a little different weight. So maybe this net is a bit too rigid, so maybe I will find something else.
Good. Thank you for the live demo.
You're welcome. Some people are visual, and if they don't understand well English, they can get a clue or an idea about.
Picture's always worth at least 1,000 words. Okay, we're up on 4 hours here. Anything else to discuss, talk about, bring up? Otherwise, like to any points to bring out here? Or shall we wrap up?
Thank you, guys, and have a wonderful night.
Thank you very much for dropping in, Armin. Always appreciate your input. Everyone does. And hope to hear some interesting developments come out of your Mexican excursion there.
Sure. My pleasure to share.
Right on. And if anyone else has anything that's interesting that's come up in their experiments, you can either present them in this particular venue next week, or if it's really good, you can present it in the Knowledge Seekers workshop. And you could send your presentation to me or through the webmaster, and make sure it gets accepted for presentation and Thursday. But perhaps you've got that flying saucer in your closet that's been hiding there for a long time, and you feel it's time for it to come out and play. Well, let us know. Let's get set up, do some PDFs or whatever is required to describe your situation and present it to the world. So it's time to get some of our closet creations out into the world to be manifest. Time to manifest the teachings that we've all learned over these years. Let's see some examples that haven't been shown before. That would be nice. Alrighty, well, let's wrap up for today then. It's been an interesting time, and I thank everyone for your participation and for attending. And once again, this is the Keshe Plasma Reactor Group. It is now Wednesday, May 30th, 2018. My name is Rick Crammond. And that's it for tonight. Okay, thanks everybody. And see you next time around. Okay, gotta stop all the streamings and conundrums here. Let's see. That one done, and that one.